Okay, so let's get into today's LeetCode bi-weekly contest. So there's still 2 minutes, so let's wait for the contest to be started and then start solving the problems. Yes, I got it. Should have decreased the threat. Yeah, so there's still 1 minute left, I guess. And we do have a lot of decent time now. I hope I can solve like 2 to 3 problems, at least 3 problems here. That would help me to become at least, if you can consider my current rating on LeetCode, it would be really good as become guardian. I guess there's no that much significance of this, but I guess at some point I just kind of reached the guardian title and I'm currently knight. So I just need to be a bit precise over the contest now to kind of become the guardian. So yeah. So I guess I need the 2 to 300 points more. Like consistently, I have to do good in contests. So I hope that I could do good now. All right, continue. Well, yes, join now. Yes, this is too slow. So it, yeah, so seems out to be a bit jammy. Mm, it's too slow. What is going on in LeetCode? Okay, so we got the problems. Get the problems. Get the problems. Let's get the 4 problems right. Yes. So seems out to be slow here. And there is no rating. 3, 4, 5, 6. So here all the problems seem to have the decent significance. Oh, the first problem is taking a lot of time to kind of load. Even the code editor. Let's wait. Okay, we're going to categories of the theme at park attraction, land use, watering, land use start. Land start time, the earliest time either right can be voted. Land division. Okay, the problem has a lot of things. Mm. My earliest time. Let's look at the constraints. And square. Uh, First land and then water, or water and land. Okay. Start time dot size m equal to water start dot size and go through the n square. So the n one would be land. Okay, so let's understand t plus duration. It finishes as t plus duration. So 2. Okay, output 9. So 6 plus water duration 0. Okay, so and one is gonna be land. Land start time plus land duration. If water start time, it's gonna be I guess I, both of them. Oh, this is a typing question. Not much really anything here. Is greater than equals to and 1. And we can kind of set up the answer variable. And we can set up the int. Um, mm, and also comma and 1 plus water duration J. అప్పుడే Oh, sorry for the disturbance. Actually, it was kind of a parents just they don't know that I'm giving the contest right now, and they just wanted to kind of make sure that they just yeah, that's it. What to do? Yeah, and we can continue, or we can even chat, leave it, and we can make it int and to equal water start time j plus water duration j if n2 is greater than equal land start I answer would be minimum of answer plus land duration and we will return the answer after the to use. Variable names were quite complicated over here. Upgrade for cloud. I don't know whether it ran or not. Okay, I guess 17 there is an issue. Land duration of I to be. Yeah, cloud saving is not there. That's 3. I got output 9. Another 14, I guess. Looks correct. Submit. It should be correct solution, I guess. I don't know why I got wrong answer. What is the start time is 50 words. So, okay, I did not get what to do now. It should be kind of 2, not 9. What is the question? So, wait, you cannot finish it. Earliest time, okay. Yeah, this is the solution, I guess. I just did not read the question well, I guess. So, what the accept sign? So, question 2. You can array and its maximum value is at most k times the minimum value. Maximum element is at most k times the minimum value. So sort the array first of all. Minimum number of elements is okay. Maximum element is k times the at most k times. So maxi should be many times of 9. Okay. So says so. Okay. Size of 1 is considered to be balanced since the minimum. Okay. So we kind of have to kind of figure out remove few elements. So possibly increasing the minimum or reducing the maximum, doing the both would do the job for us. I guess so. Now first we sort the array. So the row condition sort the array. We did sort the array now. Okay. Yes. I will reduce the minimum maximum to some extent. So how do I solve it like of n square? N is really huge here, right? So it should kind of increase, right? Otherwise, there is no significance. So what should I do? Maybe I can just use the set. Should remove some elements, obviously. Increasing the maximum is not possible, so reduce the maximum. What we can do? Reduce maxi and increase. I mean, so yeah, binary search. So we choose the minimum. So this is the minimum value. What is the maximum? So yeah, answer could be removing everything. Answer will be removing it. So low. What would be the low? So the low would be kind of I. And high would be probability. And we have to mid, which is equals to a low plus high, right shifted to ones, or divided by what? 1. Then what? So we need to check whether it is satisfying or not satisfying, and when it will satisfy if a of a times of k is kind of greater than equals to a mid. So k into 10 to the power 9. This is interesting, right? So this might kind of lead to overflow. So this should be really dealt kind of really well. Long product equals to long. We'll cast it long AI. Okay. If product image should be kind of less than equals to the product. And what will you do is answer equals to min answer and kind of I guess switch was the mid. So leftover elements which is n minus 1 plus in the left side we rejected I elements and we'll kind of try to increase the mid. Else when we do I initially did not realize the binary search, and without realizing the binary search the problem becomes really tough. N equal nums dot size. Yeah. What's so yeah, I was not yeah, I just usually kind of use a lot of AI. So where did I use it? AI. So it should be nums wherever it's A. These kind of mistakes I do. Accepted so. I hope so. Output 0. Output should be 1, I guess. So K times. Oh, the minimum. Did we sort it? Yeah, initially we did sort it. And it took it n minus 1 and value I plus n minus 1 minus mid. So mid mm, I. Okay, mid is fine. N minus 1 plus n minus 1 minus mid plus I. How can it become 0? So in order to become 0, it should be, yeah, 1 k times. So this product should be greater than equal to options. And this should be give us correct solution, I guess. Submit. This should be the solution, yeah. Third problem, let's see. Again, two categories. Water time, start time, run time. Okay, this time what? I guess the same problem. This time the constraints are a bit huge. So let's get the code from the first problem to kind of understand how can I optimize this. So this is the code, and the only difference between first problem and this looks out to be the what the constraints. So here n into that j will not work since it's 5 into 10 to the power 4. So the constraints are huge. Like I have to kind of do some sort of optimization here. Yeah, I guess it's about prefixes and suffixes. Yeah. I can fix one of the right first and then try to kind of use. So the first try, we'll try everything to be the first right, and then we'll try to search for the second right. So we'll sort it according to the start time. So no, yeah. So the start time should be greater than or less than. So if the start time is greater, then it's fine. Okay, fine, right? It's always fine. So what? We can always pick everything. But when the start time is less, we'll pick this one. When the start time is greater, we'll pick this one. So we'll kind of sort everything, and then we'll use suffix and prefix minimums to kind of crack the problem. So prefix minimum and suffix minimum, or we just need the suffix minimum. So the problem gets solved in n log n time by using binary search. So what we do now, kind of set up the traits or use a vector P, or we can even sort by ourselves without using the vector P. So we'll use sort. Okay, what should we exactly sort? So let's use vector pair. I guess vector pair would do the job well for this kind of problems. Why vector pair? Only because you can see that vector of like pair of int land and one for the bottom, and go to that, going through it, and what we can push back is, and we'll push back land dot push back. What we'll push back is land start time of I and land duration. Okay, I guess duration and everything will not kind of. Oh yeah, duration I. Or you can even use the end time. That will not kind of impact the solution. But I guess the duration would even do the job without considering the end time. Or I can even take the end time because end time does make a lot of sense. And for that we have to take the minimum duration. So the duration also plays a really important role here. So let's keep the duration and we'll kind of go through the entire column I plus plus. So water, we just push back water dot push back water start Time J. I just wanted to ensure that the recording is fine or not. Yeah. So what I comma land water duration of what I and sort land dot begin and comma land dot and sort water dot begin and then water dot end, and then we'll try out everything, and after trying out everything we'll just find out the minimum. We'll again binary search for that, and after binary searching the start point, so we'll kind of work out, we'll kind of go through the land, and we consider this to be done first. We kind of okay. So for that, we kind of use the answer again with int max. So these things don't kind of impact the solution. I have to be quick here. There's less time. So since my target is solving. So this is going for the we're trying out everything for that. Int j I equals 0, I less than m. I think we can use the lower bound template to kind of directly find out the lower bound instead of binary searching. So that makes out of the so for the suffix maximum and time for both of them. So we just need to kind of return out the suffix. So we can kind of write out the function for the suffix instead of obtaining. So what we need is the vector of in suffix, and we also need the prefix minimum, right? Vector of pair pair of int comma int will have the address, give it array. So and we'll have the length to be suffix array size, array dot size, and vector of int, and we have the suffix would have a size of kind of n plus one, and if the that's not going to be issue here. Suffix n plus one would have, since we are kind of considering what a suffix minimum, right? We can take an int max since we are considering the suffix. And now we go through the array from the backwards, and then I create suffix I equals to suffix min of suffix of I plus 1 and arr of I dot first plus arr of I dot second, and then we will return out the suffix instead of repeating out the calculation section. Turn suffix, and similar thing for the prefix. I'm just copying out some sort of templates. So we just kind of need to consider what I'm doing. So this time it will be prefix duration minimum. So we are considering prefix. So for the prefix again, we will kind of be really specific. So prefix, what is prefix? Yeah, we are doing nice. And I can just kind of do that, but let's go with again in n equal arr dot size. And this time we can kind of be really specific what we are doing. This is a really huge implementation problem. Vector of int, this time it will be prefix instead of suffix. Prefix, and it will be n plus 1. And since we are typing what minimum duration again, int max for int I less than ni plus plus what next what first index that is greater than that. So I can binary search for that again. And then what? I'll use long for the answer to kind of prevent the overflow. the fucking overflow stuff. So here, what can I do? So I go through the array prefix here. Prefix of I plus 1 equal min of prefix I comma dot second again, just considering the duration is enough. We'll return the prefix. Fine. So we're done with the basic idea. What we are intending to do in the array. So calculate the prefix, calculate the suffix. So we'll store everything below what below this. After sorting step, we'll store everything. What will store everything? So how will we store? So we will store by kind of first we want vector. We need the prefix for the water. Water. Uh, suffix water equals to suffix and water. What is suffix of water? Yeah. And now we just set up the answer to be yeah. Instead of int, I'll just use long here to kind of eliminate the fucking kind of the overflows. Like, so I am taking it long like because that should eliminate the issues. Or I can even take the int to kind of. And then what we do? So we have the start time and the end time. And what we do is land of I dot first plus dot second, and we do what we do is bind up I not binary search. I guess I can give it mint lower bound of what water dot begin, and what we do is a pair ending and int this pair, and what I can do is kind of water dot. So we got the ITX where it's starting. Yeah, exactly. So ITX will be, I guess, prefix. So you can always take the prefix. So you got the IDX. So considering up to that IDX, the prefix would be. So if the IDX was 0, then you will take 0. So if the prefix, if prefix IDX is not int, if IDX is not equal to 0, no, I'll take this. Uh, answer would remain of answer. And what prefix of IDX? So this is the duration if you want in the prefix plus the ending. Obviously, we should start after ending. Prefix and prefix of water. This is really important. And just use the binary search, leveraging the binary search here. And if IDX, just considering the edge cases here, if what uh IDX is not equals to M answer, it will mean of answer suffix. I guess if it's beginning after that, that will be suffix of IDX. I guess since there's no addition here, in this always keep suffix of IDX, I guess. So this is it. This would just do suffix water. This is really important. And again, this thing you can just copy. Everything you can just copy out here. for the second one. Just save some changes. This is the thing. Auto. So we just comment it out and we land wherever the land. Land capitals and we land again practically. We land it water again M. Water. We land here when we search. Land again here when we search. And here again we land. And again here it will be prefix land again practically. Prefix land. And here again it will be suffix land. It will be land. Right. Okay, so how to use lower bound for vector pair? Let's try. Okay, so then what's the mistake here? What's getting comments out of sex trans? Lower bound 39. I know what's wrong. Okay, let's use a vector. I'll make pair to do the job, I guess. So if there is issues, we'll see what happens. Yeah, so you have to use a make pair to kind of solve the issue. Make pair function. Make pair go prefix land here it will land prefix land. The variable names were not specific. So here I got a 9, fine. And here I got a 14 for the second one. Yeah, should be correct. So this is the solution. According to me, I got the accepted sign. So this was a quite implementation based problem. Let's go to problem D. And given array nums of length queries LR threshold. Okay, this looks like again a hard problem. I should have to be able to solve this. Just reload to kind of check whether I got this solved in a list or not. Okay, let's finish the contest. Try to finish the contest a bit quicker. If I'm not able to solve, let's see what happens. We're going to add integer array nums of length and array queries where queries are li and ri and threshold. Return an array of integer where answer I is equals to the element in the subarray. Let's just cross out solve problems to kind of get out of the distraction. So we do an array queries lr. Okay, return an array of integers. Answer where answer is equals to the element in the array from into array. Number of variables as selecting choose the smallest in case of time. Highest frequency. And square should solve able to solve. But the queries, okay. What? I did not even understand the question here. Basic idea. Let's go for the ranking a bit to kind of check where I stand now. I guess four problems a lot of people would have solved. 1,000 people solving three problems. Yeah, there was nothing more in third problem. I have to be quick now. The four problems like this is just easy for the ones who know like I'm a starter coding. Nums length and queries li and ri and threshold return an array of integers and size is equals to the subarray from a li that it is threshold selecting the element with the highest frequency. Okay, smaller element in case of time. So we have queries, fine. It leaves threshold and has the maximum frequency. Okay, so if it is greater than that, then we'll consider its count. So I can use an annotated map, but still it could be slow and lead to TLE since I have to answer for the queries. So threshold, etc. etc. This is a range query or somewhat a merging kind of code. I don't know, I cannot solve it, I guess. At least threshold. N square and cube. For every value, what is the minimum threshold? Says that this is the answer. So the array has some elements. Forget about answering about the range. And number of elements is equals to that. We can have the count, segmentaries, and victories. Number of queries is huge. There is some data structure needed here. I guess segmentary, since asking for the queries. So I guess O of n, no, not acceptable. Okay, threshold li has to okay. So what should we arrange? And we have the number of numbers, and we have count. Highest we pick the highest frequency, and in case of time we pick the minimum element. Okay. What is the minimum value up to which this is the threshold? So that is a good condition. So we would have the greater than this. Okay, answering the queries is a bit challenging. We cannot even maintain a hash map. Looks like segment tree, looks like that. Okay, I got the solution, right? We can use coordinate compression, compression to for uh, around 6 times of 10 to the power 4. Think after compressing. So the 6 into 10 to the power 4, right? Very small range. Still applying that 4 times, and that is again segment is still not efficient. But this is the basic step. Take all the values in the queries, take all the nums, apply coordinate compression, and then try to solve the problem. Fine, right? Applying coordinate compression is really important to kind of reduce the values to from 10 to the power 9 to 6 into 10 to the power 4 around after that. So I reduced the range, I reduced everything, then what? And I can then what should I apply? When is the answer this? That is what we need to focus on. So for each query, the answer can go from here to here, or the range of values here. So let's apply the coordinate compression first of all. Applying coordinate compression. I'm removing this comment. I guess apply coordinate compression in the first step. Okay, possibly into comma, compress. Apply sort, begin, and comma, bare total, and use post increment. Compressing the coordinates, and then I guess I used it also went to the I did not go through the queries or some sort of a forensic. I guess the third one, right? Second number queries total reducing the trends points a bit. Post author value post. This will be post and compress, not compress. And we go through the nums, and this time we use the address. To go through the address, and post equal compress position. And similarly, we go through the queries, ampersand post query post to equal compress. We compress the coordinates here, and then next step. So the this 10 to the power 9 can be really less here, around whatever I said. After that, how can I answer each and every query now? After compressing, how? What is the element with the maximum frequency that is greater than the given threshold, right? Number of elements that are greater than threshold. I don't know now. I really don't know now. I reduce the coordinates. After this, I'm not getting any idea, but this is the basic step. Okay, this one, some of there is no condition. Constraints are really huge. What to do now? Forcing should not be good. So the threshold where it reduces, the value also reduces, right? So what is the minimum threshold for which this is the answer? So minimum threshold, that is what we need to buy and research for. At least or greater than. I guess it's at least, right? We go through the array and 1 8. So we cannot kind of do really big things there and 1 8 thing. So if I do the calculation, it is not exactly going to be 1 8. 10 to the power 4 times 10 to the power 4 upon 2. So it is around, I guess it's gonna be a 4, 5 into 10 to the power 7. Fine, this is still not a really huge number. Applying n square and number of things that are having this. I can use a map. No, I cannot use a map. So now again, time to be a bit deep. Okay, values LIRI. what is the minimum threshold up to which this is the answer for that. So we can bind research there, but like querying in the range, right? Hmm. Okay, negative one of such element exists. So we can query for the range maximum, or we can even store the maximum of the range. It is not a big deal. Let's query them. That's okay. Let's follow that. Okay. So let's try to find out the contribution of each and every element, up to which at some point of time it should be the greater than this. Yes, comparison should have some use, right? Binary search for the maximum value, I guess that is possible. Fine. There are not that much queries, right? This many queries are there, which is not a huge thing. So we can binary search in each query, and we can go through 10 to the power 4. No, we cannot. So we have to find the prefix count. Interesting. So for every I can do it, keep on sorting the queries with some, yeah, sorting the queries with the start times, or yeah. Some, I guess we have to think a bit algorithmically. So what we have the li, ri, and threshold. What can you do with this? So yeah, we can also get it all the values greater than that. One having the maximum count. Segmentary spinning tree is what? A question mark here. I'm not getting any idea how much. Yes, it's been 1 hour since we have been discussing the problems. So since I'm not getting any idea, what should I do? Uh, what should I do now here? I've just compressed the comments. After that, no idea. What is the data structure segment trees? No, fabric trees. I don't know whether fabric trees, how do they work? I only know segment trees. Sorting the queries, maybe. What is the answer? Okay, I guess I'm leaving it. Half an hour, it's impossible to kind of solve. Or even I'm feeling a bit hungry. I did fast solve the three problems. Speaking range maximum, yeah. Negative one has been done. Using segment is you can find the range maximum. Done. Now how much? Oops, wait, let's see. At least threshold times. I don't even understand the problem. He was asking which number which it is at least threshold times. Okay, threshold is obviously less than okay. So now this implies every element is kind of reduced. It appears at least this so. So applying coordinate compressions is enough. Don't go through the queries. It doesn't make any sense. So I was just mistake. Okay. Okay. Compress and comment it at least threshold times. So you can go through into log 2 around 13. This is what we get time complexity. And we have to only query. So we are taking out what we have to keep on updating, and that's update will also cost us a bit huge. Uh, 10 to the power 4, 10 to the power 1, 10 to the power 4. Okay. The main thing is segment updates. Okay. I actually reset the problem. That's why it took me a lot of time. Then apply segmentary. Updates are really costly. So we go there with threshold. Yeah, threshold is come threshold. इसमें क्या करेंगे अभी? We'll try to go through fixing one threshold. Okay, 10 to the power 4 again thresholds. Most okay.